welcome to another session of SEA Time Mathematics. I am Jacqueline Pariag, and I'm going to be your tutor for today's session. Today we are going to look at percent and percentages. Before we begin, I would like you to make sure that you have some writing material, maybe a notebook, an exercise book, and your pencil ready so that you can make some notes and you can work along with me. We're going to begin now. Today we are just doing revision, so you would have probably done all of this already in your class. Our learning targets for today: develop an understanding of percent, express quantities as percent of other quantities, calculate percent of quantities, and solve problems involving percent. Randy had $100 in his pocket. He spent $5 on a bottle of water. What fraction of his money did he spend on the bottle of water? So we are going to model our problem, and to do that, we are going to use a flat from the base 10 materials. This is a flat. It is made up of 100 of these unit cubes. So I'm going to rest the flat down. This is 100. The 100 represents the whole, which is the amount of money that Randy has, $100. And I have next to the flat 5 units, which represents the $5 he spent on the water. So we want to know what fraction of the whole he spent on the water. So I can take these and I can rest it on the flat, and we will see that our fraction is, I hope you can see it clearly, it's 5 out of 100. Now I can represent this on a grid. This grid is a drawing of what I have on the table. So this is my 100 grid, and I would have shaded 5 of those to show the fraction. Now, you are seeing something else on this grid. I have used something else to represent this fraction, but we're going to talk about that in a while. So let's go back to our slide. So this on this slide is what we have shown on our grid, and it represents 5/100ths of the money that Randy used from his pocket to purchase the bottle of water. As you will see, I have shaded 5 of the little squares. There's 100 squares on this grid, and 5 is shaded to show 5 out of 100. Now, the question asks for the fraction. We can reduce this fraction to show that this fraction, if we reduce it, we can get 1/20th. So the fraction of money that Randy spent on the bottle of water is 1/20th. 5 into 5, 1. 5 into 100, 20. If you look carefully on the grid, you will see the grid is also divided into 20 parts. So this one whole part here represents 1/20th, or 5/100ths. So 5/100ths is equal to 1/20th. Do we want to represent this fraction another way? This is our grid. I'm shading each of the 5 squares. So I have the 5/100ths, or the 1/20th of the grid, shaded. How else can we represent this fraction? What is 5/100ths? 500ths could also be written as a decimal, like this, 0.05. And we read this as 500ths or 0.05. We can also represent the 500ths as 5% or 5 with the percent sign. So all of these are different ways of representing the fraction of money that Randy spent on the bottle of water. Let's look at another problem. Mr. Peter measured a piece of string. The string was 25 centimeters long. What fraction of 1 meter is the length of the string? On the slide, I have part of a meter rule, which shows 25 centimeters. And this is the length of the string. What we are being asked is what fraction of 1 meter is the length of the string. So I cannot draw the full meter. So what I'm going to do, I'm going to represent this problem using some bars. The resource I'm using for this is called a set of Cuisenaire rods. And they are available in your schools. They are a set of rods that are colored, and each colored represents 1 or more unit up to 10 units. So we have the white, which is a 1 cm cube, representing 1 unit. We have the red, representing 2 units. We have the green, representing 3 units. The purple, 4 units. Yellow, 5 units. Green, 6 units. Black, 7 units. Brown, 8 units. Blue, 9 units. And orange, 10 units. And this is very similar to our flat because it's the same length. So 10 centimeters is used to represent 10, just as in one of the sides of our flats. I'm going to try to represent the fraction of the meter using the Cuisenaire rods. So I'm just going to put this aside, and I'm going to take some from my bag, and I'm going to use the brown, which represents 8. So this is going to represent my whole meter. Now, how many 25 centimeter pieces can I get in this whole meter? So I'm going to try to use some smaller ones. This one is representing 2 units. Let's see if it's going to fit. Yes, they are. So 4 of these are the same length as the one of these. So if this is representing my whole meter, then each one of these, and I'll pull them apart a bit so you can see that there are 4, each one of these is representing 1 out of 4 parts of this whole meter. And that is 25 centimeters. Right? So this is 25 centimeters. Is there any other way I can represent this fraction? Let's look at it on the slide. This is our model of our problem 2. So we have our whole meter, which is represented by our brown rod, and we have each of the 25 centimeters represented by the smaller unit. And as we see there, 4 sets of 25 are in 100. So the piece of string, which is 25 centimeters long, is 1 out of 4 parts of a meter, or 1/4 of a meter. I am also going to represent 1/4 on the grid. So here I have a grid which is the 100 squares, and I am representing 1/4, which is 25 squares. 25 out of 100, which is equal to 1/4. Is there any other way I can represent that part or that fraction of string? 25 hundredths. So 25 hundredths is the same as 1/4. And 25 hundredths can be written as 0.25, and it can be read as 25 hundredths, or for convenience 0.25. So the length of string that Mr. Peter measured is 1/4 of a meter, or 25 hundredths. Is there any other way we can represent this fraction? Yes, we can. 25%. So 25% is the same as 25 hundredths, and that is the same as 1/4. And I can write 25% in words, or I can write 25% with the symbol which you know. So we can use our grid, and we can represent 25%, or 1/4. So if you have a checkered line exercise book, you can draw a 100 grid, you could cut it out, and you could try to represent your fractions and also your percent. So we're going to talk a little bit about percent. What is a percent? A percent is a fraction. It is one part of a whole, but it's a very special whole. This whole is divided into 100 parts, as we would have seen with the base 10 flat, as well as with the representation of the grid on paper. So it's a fraction with the whole divided into 100 parts. So if I shade one of those parts, that is the same as 1%. 1% is also represented on the flat with 1 unit. I can also represent other percents. What about 10%? So 10 out of 100 could be represented on the grid. I could also represent 10 out of the 100 using 1 rod. So this rod is 1/10 of 100, or 10% of 100. So a percent is a special fraction with the denominator as 100. It's a fraction with a denominator of 100. What does percent mean? Percent means out of 100 or per 100. So it means in every 100, this is the part that is represented. As we saw with the 5%, the 1%, the 10%, and the 25%. We also saw a percent is 100th. So here we are linking the percent to the decimals. The symbol for percent is written like this, with 2, the circle, then the slash, and then the circle. But look at something very interesting. An early symbol was this. And this symbol was around the years 1600, 17th century. And this was the symbol for percent. And eventually, this symbol was changed to this one, where this was removed and a slash replace the dots, dotted line in the middle. So when you have the time, you can research and you can find out more about the symbol for percent and how it was used way back in the 17th century. It's very interesting. Good. We're going to go on now to looking at some words that are linked to 100. You realize that since we have been talking about percent, we have been looking at the number 100. So let's explore some words that are linked to 100 and that are linked to percent. Century, 100 years or 100 runs in cricket. Centennial, 100th anniversary. Again, it is linked to the word, to the number 100. So the centennial is a 100th anniversary. A centenarian, a person who is 100 years or more. I wonder if you know anybody who is a centenarian. Maybe your grandma or grandpa, or even great-grandma or grandpa. Once that person gets to 100 years and beyond that, they are called a centenarian. And again, we are seeing that word, that beginning word, a centimeter. This one we are familiar with from measurement. A centimeter is 1/100th of a meter. We know that one pretty well. And then we come to our words that we are dealing with today, which is the percent, which means per 100, or percentage, which is a number or amount in each 100. So boys and girls, do you think that the words percent and percentage are the same? Are they used interchangeably? Actually, they're not. There are two different types of words. Percent, it's an adverb. It's never used alone. It's usually used with a number before it, and usually the word of after it. Percentage is a noun and can be used by itself. So the words are very different, although they are referring to a number or a quantity out of 100. So when we get to some of the problems later on, you will see how they are used. So next time you have to use the word percent or percentage, think about which one you require. So now we are going to look at some other models for percent. And the first one we are going to look at is the one for 50%. So this time I'm going to use, we have the grid for 50%. So I have my grid of 100 squares and 50 of those squares are shaded. So this represents 50%. It also represents a half, and it also represents 50 hundredths. It represents 5/10ths. And all those fractions are related to the 50%. We can also represent 50% using a 100 disc. So here you are seeing a 100 disc. This is a disc that is divided into 100 parts, 100 equal parts. And on my model here, you are seeing half of it is shaded. And I could simply represent that on my fraction board. So this fraction here that is represented is a half. It is also 50%. I can also represent my fraction using my Cuisenaire rods. So which one can I use? I can use a number of them. So I'm going to move this one aside. I can represent it using the 10 rod. So for this to represent 50%, so we are going to use yellow to represent 50%. So as you could see, the length of 2 of the yellow rods are the same as the length of one of the 10s rod. or the orange rod. So I can represent 50% like this. So I am showing half of the rod by covering it with the yellow rod, which represents a half or 50% or 50 hundredths. So these are all different ways of representing 50%. So far we have looked at 25% and 50%. What about 75%? So there are different models for 75%. So let's begin again with our grid. And you can do this, you can practice home with your checkered line exercise book, or if you find a grid that you can cut out and you can use it, you can color to show different percentages. So this is my grid, and my grid shows 75 of those squares that are shaded. So this is 75%. As a fraction, it is 3/4. As a decimal, it is 75 hundredths, or 0.75. I can also show 75 on using my disk. I've represented 75% or 3/4 or 75 hundredths. Right, we're going to move on. So we have been talking about percent, we have been talking about parts of the whole. What about the whole? And this is how we represent the whole. So we can represent the whole using the grid. This is 100%. This represents one whole with 100 smaller units. So the flat could represent one whole. And of course, we can represent the whole as a circle. So this is one whole. What percent is one whole? 100%. So the whole is always 100%. And that, girls and boys, is very important information for when we are solving problems. We must recognize what the whole is and what does the whole represent. And the whole is always represented by 100%. So 100 of the parts are shaded, which is all of the parts are shaded. So boys and girls, I know you are familiar with the conversion table. What I have done is to use the different models to show you how we can represent these fractions using as a fraction, as a decimal, and as a percent. So it's very easy, and we could link each of them. We see some of the examples we have here. 1/10 is the same as 0.1, and it's also 10%. And we have seen that on the grid. We have seen a quarter. A quarter as 25 hundredths, but also as 25%. We have seen the half, which is 50 hundredths or 5/10, but it's also represented as 50%. And we have looked at the 3/4 fraction, which is represented also as a decimal as 75 hundredths and also as 75%. And we have, of course, our whole, which is represented as 100%, or one whole as a decimal, which is 1.0. And you can continue building this table as I'm sure you have been doing. And when you can use this table to compare the sizes of the fractions. So it's not always easy to compare them when they are stated as the fractions, because then we have to use equivalent fractions to compare them. But it's a little bit easier when we can compare them as decimals and also as percent. You can see the size of the fractions. So now we are going to apply percent and percentage to some problems. Boys and girls, we are going to calculate some simple percentage of quantities. Before we do that, let's go back a little bit on what we have done so far. We have looked at models for percent, and if you recall, we have used models that are 100. There are so many models of 100 around us. There are so many examples of percent and percentages around us. Do you know any? For example, your phone. If you look at the phone, and somewhere at the top, you are going to see the percentage of charge that the phone has. If you have a phone nearby, look at the phone and see if you can see what percentage of charge is left on the phone. What about a laptop or a tablet? Similarly, at any point in time, you're going to see the percentage of charge. My Fitbit has a charger. When I plug my Fitbit into the charger, it tells me what percentage of charge I have. When I look at my Fitbit now, it's also telling me I need to make some steps. So let's get this lesson on, and I'm going to make my steps after. So before we go to calculating simple percent of quantities, we must understand a few things. So far, as I said, we have been dealing with 100. But what about amounts that are not, or quantities that are not 100? Some may be more than 100, some may be less than 100. So how are we going to calculate simple percent of quantities that are not 100? Boys and girls, what we have to do is to use equivalent fractions. So what we are really doing is finding equivalent fractions that are the same as the percent that we want to find. And I'm going to demonstrate this using a problem. So on the board I have a problem, a simple problem. Amy scored 80% of the total marks on a test. The total marks on the test was 60. How many marks did Amy score in the test? So we have been given some information. We have been given Amy's score as a percent. Amy scored 80%. We have been given the total marks on the test, which is 60. What we don't know is how many marks did Amy score in the test, and how are we going to find this out. What we have to do is to remember when we are solving problems in which we want to find the percent of quantities, we have to recognize what is the whole. We must know what is the whole. We must know what is the part. And we must know what is the percent we want to calculate. So let's look at this problem and see if we can figure out, represent these on the board. So we have the percent, which is 80. So I'm going to write 80%, which is 80 over 100. So 80% is equal to some number, which is Amy's mark, which we don't know, and I'll represent that with a box, out of the total marks on the test, which is the whole. So the whole in this case is 60. So what we are really calculating is an equivalent fraction. The number of marks out of the total marks, but this is equivalent to 80%. Now I can do this very quickly here. If I reduce 80%, I will get 4/5. So I could say 4/5 is equal, this is a number over 60. Now, what did I do to get 60? How did I go from 5 to 60? As we know with equivalent fractions, whatever number I multiply the denominator by, I'm going to do the same thing with the numerator. So in this case, I'm working backwards. So I'm going to multiply. If I multiplied to get to 60, if I multiplied 12 by 5, then I'm going to multiply the numerator. I'm going to multiply 12 by 4. And my answer there is going to be 48. So the number of marks that Amy scored is 48. And if I want to check my answer, I can do that. I can do that. I'm going to represent the part, which is the number of marks, over the whole, which is 60. And if I reduce it, I'm going to get 4/5. And 4/5 is the same as 80 over 100. I can multiply by 20 at the top. I can multiply by 20 at the bottom. I'm going to get 80 over 100, which is equal to 80%. So what I have done is checked over my answer to make sure that I worked out 80% of the marks, 80% of the total that Amy scored, which is 48 marks. So to recap, when we are finding simple percent of a quantity, what we do is really use equivalent fractions and represent the quantities as an equivalent fraction. Now, another way we can do this, multiply the percent by the whole. What you are really doing here is finding the 80% of the 60. In other words, which number out of 60 is the same as 80 over 100. And when we calculate this, we are going to get our answer, which is 48. So there are both ways we can work it. We can simply follow the equivalent fraction, use of the equivalent fraction, or as we are accustomed, we can do finding the 80%, multiplying by the whole, and then getting the part. So boys and girls, in our last problem, we found a simple percent of another quantity. In this problem, we are going to look at expressing one quantity as a percent of another quantity. So I have a problem on the board. I'm going to read it. A set of 25 cubes are shown. What percent of the set of cubes is green? So I'm just going to demonstrate this with some actual cubes. I'm going to use my Lincoln cubes. And on the table, I have my 25 cubes, and they are 4 different colors. Now, I want to know what percent of the cubes is green. So I want you to remember what we said in the first problem. Whenever we have a problem with percent and we have to do calculations, we should identify what is the whole, what is the part, and then we work the percent. Sometimes we will be given the percent and we may be asked to find the part. So let's look at our cubes. So I have 25 cubes here. Out of the 25 cubes, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 3, 4, 10 green cubes. So I want to represent the 10 green cubes as a percentage of the whole. So let me identify what is my whole. My whole is 25. So to begin representing my fraction, I'm going to write 25. And now, how many green cubes do I have? I have 10. So, and the question is asking me to find out what percent of the set of cubes is green. So I have to represent this as a percent. So I'm going to begin again, first of all, from where we are, what we know with fractions, and I'm going to try to use equivalent fractions. So I want a percent, so therefore I want a fraction with a denominator of 100. So what am I going to do to this 25 to get 100? As we know with equivalent fractions, we multiply numerator and denominator to get the equivalent fractions. So I know that 25 times 4 will give me 100. So I'm going to do the same thing at the top. 10 times 4 is 40. So 40 over 100 is the same as 40%. So very simple. The percent of cubes that is green is 40%. Can I calculate that any other way? Yes, we can use the multiplication, which is really the equivalent fraction method in a simplified way. So I will write 10 over 25, and I'm going to multiply by 100 over 1, because I want to find what this number is, this number out of 100 that will give me this equivalent fraction. So I'm finding this fraction of 100. So again, 25 can go into 100 4 times, and I get 40, but that's not my answer. I must include the percent, because this is a fraction which has a denominator of 100. So 40% of my cubes are green. Similarly, I could calculate for the others. If I have what percent of the cubes are yellow. So I have 6 yellow cubes. So I can write 6, which is the part, out of 25. And what will I get? %. So 24% of my cubes are yellow. The blue, I also have 6. So 6 out of 25, I'm going to get the same percentage of blue cubes out of my 25. Right, I have now 3 red. So I'm just extending the problem so we can see how we work the quantities expressed as a simple percent of another quantity. So 3 out of 25. I'm going to write 3, which is my part, 25 being my whole, and I can do it by multiplying by 100, or I could simply use the equivalent fractions method. So notice we have twice as many blue or yellow cubes as we have red cubes. So therefore, the percentage of blue or yellow cubes is twice the percentage of red cubes. So this simple problem and demonstration shows us how we can express one quantity as a simple percent of another quantity. Remember, always identify what is the part and what is the whole before you are calculating the percent. So boys and girls, we are going to solve some more problems involving percent. And as we know with problem solving, we will try first of all to read and understand our problem. So let's look at the problem on the board. I'm going to read the problem for you. You can read along with me. Aline collected seashells on Saturday and Sunday. He collected 3 times as many seashells on Sunday as he did on Saturday. What percent of seashells did Aline collect on Sunday? So let's take a closer look at the problem and see what information we got. So we know that Aline collected seashells on 2 days, Saturday and Sunday. He collected 3 times as many seashells on Sunday as he did on Saturday. And we are asked to find what percent of seashells did Aline collect on Sunday. So what is our answer going to be? Our answer is going to be a percent of seashells. And what can we do to solve this problem? So we try to devise a plan that we can use to solve this problem. Notice we have no numbers in this problem. What we do know is that on Saturday he collected 1 part and on Sunday he collected 3 parts. So very simply we can express the fraction that Aline collected, the fraction of seashells that Aline collected on Sunday. So on Sunday he collected 3 times as many. So altogether for Saturday and Sunday there are 4 parts. Remember, we want to identify the whole and the parts. So we have 4 parts. But on Sunday, he collected 3 of the 4 parts of seashells, of the total for the both days. So the fraction of seashells he collected on Sunday is 3/4 of the whole, or the total number of seashells. And in this problem, we do not need to know what the whole is because we are simply asked for the percent. So all we have to do is to convert 3/4 to percent. And of course, we want a fraction with a denominator of 100. So I'm using the equivalent fractions method. I'm going to multiply by 25. And this is a very simple and common percent. So my answer is 75%. I can also multiply by 100, find 3/4 of 100. That will give me the number that forms part of the equivalent fraction and represents the percent. So and we must remember to include our percent sign because that's what the problem asks us to find. Not a number of seashells, but percentage of seashells. And that's our answer. Very simple. So boys and girls, let's look at another problem that is involving percent. And this problem is slightly adapted from a problem in the essay paper, the essay math paper of 2013. So let's begin by reading the problem. A netball team played 16 games. The team lost 3 games, drew 1 and won the others. What percent of the total number of games did they win? So we're going to examine our question, our problem, and try to figure out what it is we need to find out. So we know the netball team played a total of 16 games. They lost 3 games. They drew 1 and they won the others. What percent of the total number of games did they win? So again, as we remember in problems like these, we identify the whole, the part, and then we will probably find the percent if we are asked to. Okay, so let's see what we have. So we know that there are a total of 16 games played. So I can make a very small table. Out of those 16 games, we know that some were won, some were lost, and some were drawn. So I have the information for what was lost. 3 games were lost, and 1 game was drawn. I have to find out how many games were won. And it's very simple numbers, so that's going to be very easy for us to do. So 3 and 1 is 4. So the number of games that are won will be 16 minus 4, which is 12. Right, so what I'm asked to find is what percent of the total number of games did they win? So I need to express 12 as a percent of the whole, which is 16. So 12 over 16 multiplied by 100 over 1. And I'll work this. We can go, 4 can go into 12 3 times. 4 can go into 16 4 times. And again, 3 by 100, 3/4 by 100 will give me 75%. So they won 75% of their games. Similarly, if we had to find the percent of the number of games lost, we can express the number of games lost as a fraction of the whole, 3 over 16, and then proceed to calculate the percent. Similarly, we can do the same for the number of games drawn. Let's look at our final problem for today. So I'm going to read the problem, and this problem is taken from the SEA 2019 mathematics paper. At a school, 55% of the students are boys. All the boys and 40% of the girls participated in the school's concert. What percent of the students participated in the concert? So again, we are going to examine our problem, see what information is given, and see what we are being asked to find. So if we look at the first sentence, we were told that at the school, 55% of the students are boys. So I'm going to write that. So the percentage of boys is 55. All the boys and 40% of the girls participated in the school's concert. So we know that 40% of the girls also participated in the school's concert. And we are being asked to find what percent of the total number of students, what is the percent of the total number of students who participated in the concert. So we are required to find a percent. So again, boys and girls, we need to recognize what is the whole and what is part, and then we may find the percent. So right away, if we are told that 55% of the students are boys, we can find out what percent of the students are girls. As we mentioned before, the whole is always represented by 100%. 100% is the whole. So the percent of girls in the school, to calculate that, we are going to subtract 55% from 100%. And that is going to give us 45%. So what we have found so far is that 45% of the students are girls. The next line of the problem tells us all the boys and 40% of the girls participated in the school concert. So we already know what percentage of the boys participated. We need to find out what percent of the girls participated. So what we are going to do in this part of the problem is to use this 45% as the whole number of girls. And then I'm going to find 40% of this. So I'm going to treat 45 as a whole here. And then I'm going to find 40% of the 45. So I'm finding 40% of 45. So I can reduce, I can divide by 20, I'm going to get 2, and I'm going to divide my 100 by 20, I'm going to get 5. 45 can be divided by 5 9 times. 9 twos are 18. So this 18 here does not represent 18 girls, it represents 18% of the students. It represents 18% of the total student body. So I must write my percent. So we come to the question now, what percent of the students participated in the concert? So 55% are boys and 18% represents the percentage of the girls that participated. So my total percent of students who participated in the concert is equal to 55 percent, which is the boys, 18%, which represents the girls, and that will give me a total of 73%. So the percent of students in the school who participated in the concert is 73%, which is 55% representing the boys and 40% of the girls, which is 40% of 45%. This 45 here is going to be used as a whole. So altogether, we have a total number expressed as a percent of students who participate in a concert, 55%, 18%, giving us 73%. 73% of students participated in a concert.